Hello everyone, this is Faisal Faki. Today I'll present about water and energy sustainability. My main focus will be in discuss the energy required in water treatment, the necessary energy magnitude to transport water of each gallon to customers and how it changes from one place to another. Then we will see some of the strategy that can be put in place to reduce energy consumption and improve the sustainability of potable water system. First of all, what is the sustainability? I've read many definitions, and from my view, the most often quoted definition comes from the United Nations World Commission on Environmental and Development that shows sustainable development is the development that meets the needs of present without compromising the ability of future generations to meet their own needs. Access to water and energy are essential to strengthening human dignity and to the development of people and society. So we must find new ways to save water and energy and optimize our modes of production and consumption. We need to produce more with less. The water and energy needs of people and society. There are 786 million people don't have access to clean water. There is 3.5 billion people's right to water is not satisfied. 2.5 billion don't have access to adequate sanitation. 1.3 billion have no electricity. 2.6 billion use solid combustion to cook. The world population is increasing by 80 million people each year. By 2015, the world will need extra 55% of water, 60% of food, extra 70% of energy, and double of electricity. The cost of operation used in water treatment. Many governments spend a considerable amount of energy in treating the sewage water so that they can release as harmless as possible. In many countries in the world, the cost of energy takes about 10% of government's operation budgets. Energy, for example, in USA, energy used in water and water utilities account for 35% of energy budget. Usage for electricity in the country accounts for 25 to 40% of the operation budget for the wastewater utilities. About 80% is spent on drinking water processing and distribution costs. Another example, Australia. The consumption energy is expected to be about 130% due to the increase of the country's population. The power consumption of treating wastewater should range between 0.3 to 2.1 in Europe and from 0.4 to 0.87 kilowatt hours per meter cube in the US. The smaller facility, the higher of specific power consumption of the plant. Also, the older plant requires more energy. There are other factors that affect the power consumption, such as the design, the technology that's used in the water treatment facilities. Wastewater treatment and energy. Wastewater is a major source of untapped energy that can be used as substitute of the energy spent on the treatment process. Wastewater contains different forms of energy. These energy forms are chemical, thermal, and kinetic. Chemical energy in the cell is estimated to be about 10 to 14 kilojoule per gram COD. and the thermal energy yields about 21 megajoule per meter cube for any drop in the temperature for about 5 Celsius degrees, while the potential or the kinetic energy is estimated to use about 30 kilojoule per meter cube over 10 meter drop. This number shows the energy stored on wastewater is about 6 to 9 times higher than the electric energy needed for treatment. There's a study about the Northern Neto wastewater treatment plant found out that wastewater has about 62.8 megawatt hour per day compared to the amount of energy required for the treatment, which is about 6.8 megawatt hour per day. The high energy demand in water treatment plant is due to the aerobic activated sludge process, which require pumping of large flows into the biological tank. This process requires more than 50% of entire energy demand of the conventional facility. Also, the pre-disposal exceeds waste activated sludge treatment is expensive both like in finance and also energy. The energy that's consumption in this process is estimated to cost between 50% and 60% of the total operation cost of wastewater treatment plant. The magnitude of energy required to transport 1 gallon of water to the consumers. In the United States, the consumption of water is very high. It has been discovered that there are more than 4 billion gallons of water that are drawn daily from surface and groundwater sources of fresh water and saline water to supply domestic uses, agriculture activities, industry application, and also for the production of the thermoelectric power. However, to enable this water to reach the destinations, it needs to be transported, which require energy. In the report that released in 2002 by the Electric Power Research Institute, the cost of treating and transporting water is expected to rise by 23% by 2020 and 63% by 2050. The electricity consumed by transporting public drinking water is 56.6 billion kilowatt hour or 11.5% of the primary energy. 21.6% of power is spent on water end use. Also, about 58% of the total energy used on the water is lost from the point of electricity generation, transmission, and distribution. So it's clear that it was challenging to calculate the amount of energy that required to transport 1 gallon of water to the required place. This can only be done by undertaking individual calculations of the water supplied at particular time. For example, like in New York, about 2,700 kilowatt hour per million gallons, while it's 5,000 kilowatt per million gallons are used in Austin. California spends the largest amount of energy, which is approximately 12,700 kilowatt per million gallons in Southern California. So, to improve the sustainability of the potable water system and to reduce energy consumed while transporting water from one place to another, some policies need to be put in place. The government can come up with strategies. They already came up with some strategies that promote water conservation and water reuse, aquifer recharge that can help in reducing energy used in water supply in the US. So saving water saves energy. In the past years in the US, some states and agencies have formulated policies that will help in better management of the energy used on water treatment supply and wastewater. The national government has formulated tools that will be used by the water authorities to help in energy management. Those tools include guidebooks, energy conservation guides, and energy audit tools that will be used in educating the public and organization on some of the methods that can use to save the energy. The Environmental Protection Agency came up with Water Sense program, which makes it easy to find and select water efficient products that can help your wallet and the environment. The agency said that will help in saving about 15% to 30% of the energy spent in water supply and treatment. Again, the EPA, with the development of energy, they came up with Portfolio Manager, which is an online benchmarking tool that gives the water consumers and wastewater utilities an avenue to evaluate their energy use and compare it like with other operation to similar facility. Low energy equipment. Some of the energy efficiency improvement are gotten by implementing high efficiency aeration technologies such as high efficiency blowers, fine or ultra fine bubble diffusers. That's the one in the picture here. Water treatment facility decentralization has been used as a strategy for improving the energy efficiency in the urban water cycle, which is require less pumping and shorter pipes. That contributes to less energy used in the system as compared to the centralized system, and also the cost. From what we see before, so it's clear that water treatment, supply and wastewater treatment and disposal process require a lot of energy. It's evident that the amount of energy used in the process is very high. However, mechanism needs to be put in place to reduce the energy consumed and also improve the sustainability of the water system. Here are my references. Thank you so much to listen to my presentation. If you have any question, you can contact me and ask me. Again, thank you.